about the first two, and now today we're going to talk about exponential. But I just kind of want to review what the three types of functions are, okay? So the first type, which is the linear function, this is when we have the equation y equals mx plus b. And of course, a linear function is going to be a straight line. The quadratic function in standard form, that is the y equals ax squared plus bx plus c. And the quadratic function is a parabola. And then you have the exponential function. This is when y equals ab to the x power. And exponential functions look like a curve. More or less like that, okay? Okay, so let's talk about exponential functions. So the equation is y equals ab to the x power. There are two types. Okay, so go ahead and draw that there. Go ahead and draw the two coordinates, the coordinate plane, excuse me. And you could put the title there. Okay, so let's look at the exponential growth first. Do you notice on the example, it says y equals 3 times 1.4 to the x power. And for the exponential decay, it says y equals 3 times 0.4 to the x power. So the letter B, you notice that if it's greater than 1, it's going to be a growth. And if it's smaller than 1, like a fraction or a decimal, it's going to be a decay. Okay, so in exponential growth, the graph looks very similar to this. Okay, that's supposed to be curvy. And then the exponential decay would be similar to this. Okay, so that's the difference between the two. That's how they look on a graph. Okay, so now let's talk about the different parts of the equation. Go ahead and write down the equation. Notice how it's supposed to be y equals ab to the x power, but when we break it down, it's still ab, but the b becomes 1 plus r, and for the decay, b becomes 1 minus r. So right here, this is supposed to be minus. Let me fix that. There you go. All right, guys, so the different parts here, we're going to label each part, okay? For the exponential growth, it's going to be labeled the same, except, of course, growth will be growth and decay would be decay. So for the exponential growth, let's start with y. Y is always going to be your final amount, okay? So right here, this is the final amount. Okay, letter A is going to represent the initial amount. Like if you have an example where it says, okay, you start off with 500 mosquitoes. 500 would be where A is. Okay, so this is your initial amount where letter A is. Your starting amount, initial amount. Okay, everything inside the parentheses. This is your growth factor. And of course, with the decay, it would be called a decay factor, okay? The letter R represents the rate of growth. So this is the rate. And then you could probably guess what the T stands for, right? T stands for time. Oh, and one more thing about the rate of growth. This will always be in decimal form. So right here in parentheses, I'm going to write decimal. Okay. So your exponential decay, all of this is going to be the exact same thing except with the word decay of asymptote. Here it is a line that a graph approaches but never touches. And yesterday we said it never crosses. So we have two types that are drawn here. In pink, this is the horizontal asymptote. This is the one you're going to see this year in algebra, okay? But I also wanted you to know that there's also such a thing called a vertical asymptote. But on the EOC, you will only see it as horizontal. So whenever they're asking you questions like, what's the asymptote for this graph? It will always be y equals whatever the number is, okay? Because it's always going to be the horizontal asymptote. Now, as far as the graph goes, you'll see more or less the graph will approach the asymptote. You know, you could have it like this. And then you could have like this. So you could have different exponential functions drawn that way. Okay, so for the next part, we're going to work out of our serious workbook. If you could take that out, please. And we're going to go to page 193. So serious, page 193. Okay, so number one says the table gives values of an exponential function. Which graph is the graph of the function? So here you could graph the table and then see how the graph looks in your graphing calculator. Or you could just pick a point and then graph it and see if it lands on the graph. So for example, if I decided to pick 0 and 1. So you're going to go to all your graphs and you're going to plot the point 0 and 1. So right here, if I go to 0, go up 1, it's supposed to be right here. It's not on the graph, so A is out. Okay. Letter B is very close. They're trying to trick us there. But I don't think it's B. If you look at letter C, that one is off. And letter D, it lands on it. Now, if you're not sure, you check another point, like 1 and 3. You go to 1, go up to the 3. Ooh, it's very close. 1, go up to the 3, and it lands on the graph again. So D is the best answer. Okay? Questions on this problem? Not too bad, right? Okay, let's go to the next page. Okay, so the next page here says on number 3, the number of wolves in a wildlife refuge can be modeled by an exponential function. where X is the number of decades since population counts began, and Y is the average annual number of wolves during the decade. The data for the 3 decades is given in the table. Which graph is the graph of the function? So again, you just pick a point and see if it lands on the graph, okay? So if I pick this first one, 1 and 240, we want to see if it lands on the graph. So go ahead and check. Okay, there we go. So I decided to use 1 and 240. So you go to the 1, go up to 240, go to the 1, go up to 240, 1, go up to 240. You should be able to tell, and if that doesn't work, pick another point, right? And see if it works out. 3, 135, 3. Oh, I could already see the best answer. What do you guys think? Tell me in the chat box. Which one do you think is the best one? Yeah, very good, guys. A is correct. All right, let's go to the next page. So we're on page 196, number 9. Is that correct? Did I skip some? I skipped some, didn't I? Let me go back. Oh yeah, they're at the bottom. Okay, number 5 at the bottom. This is from page 195, sorry. So number 5 says, what is the y-intercept of the graph shown below? Well, where does it cross the y-axis? Ooh, easy, right? Which one is it? Yes, very good, guys. Yep, it is letter A. It crosses it at -3. Okay, number 7. The graph of an exponential function is shown on the grid. Which dashed line is an asymptote for the graph? Okay, here we go, asymptotes. Remember I told you that they're always going to be horizontal, right? So pick the one. Remember, the definition of asymptote is the line that a graph approaches. It's the one that it gets close to. So it gets closer and closer and closer to that line. Which one does it get closer and closer and closer to? Okay, so I see here D. What do you guys think? Anybody else? Yes, so listen to the definition again of an asymptote, right? Asymptote is a line that the graph approaches and it gets very close to it, but it never intersects. And here you want to look at this and see which one is better. Would it be line R, or line S? So that is correct. It is line R. Even though the graph looks like it touches line R, it actually does not touch, and it's going to get, you want to pick the one that the graph approaches the closest to, okay? Because that's the definition of an asymptote. From between line R and line S, the graph gets closer and closer to line R, okay? So line R is the asymptote. So right here, the best answer is letter C. Okay, let's go now to the next one. Number 9. What is the value of the y-intercept of the graph of h of x equals 18 times 4.5 to the x power? Okay, so the y-intercept, is going to be the same thing as the initial amount. Which one of these is the initial amount? That's the y-intercept. That's right, guys. B is correct, 18. Okay, number 11. The graph of an exponential function is shown. What is the asymptote of the graph? Ooh, remember, the asymptote has to be horizontal. So where does it look like the graph gets really close to a horizontal line? Which one would it be? It definitely cannot be A, guys. Don't pick A. You know why? Because if you're picking A, it is a vertical line. It's going through the X value. No, it's not A, okay? So don't pick any that say X equals. Oh, I'm seeing some good answers. You are correct. It is letter B, y equals 4. Very good, guys. Okay, let's move on. Number 13. Which statement about the graph of y equals 3 times 0.5 to the x power is true? So here it says, letter A, the graph includes the point 2 and 3. Okay, in order to check if that's true or not, because we're looking for the one that's true, you're going to get these points and just plug it in. So you actually have 3 equals 3 times 0.5 to the second power. You get your calculator and check if they're equal on both sides. Okay, so I actually don't need the calculator, right? You could do 5 to the second power is 25. So it's actually 3 times 0.25. And if you have 3/4, you end up with 75 cents, right? So is 75.75 the same as, is it equal to 3? No, so A is out, okay? If you are still trying to decide between paper and taking the test online, do you notice how I have to write this out? I mean, you could use scratch paper, but if I had to write this out, you have to write it on paper. So if you're going to decide to do online testing, definitely make sure you get scratch paper from the teacher. If you do it on paper testing, perfect, because you just write on it. Okay. Letter B. The coordinates of the y-intercept are 0 and 3. Well, we just learned that the y-intercept is the initial amount, right? This one right here. And that is correct. I saw some of you saying, yep, that's it. Let's see. The graph increases from left to right. This is wrong because it doesn't increase. It actually decreases. So, yeah. And then letter D, the equation of the asymptote is y equals 3. This is wrong because when you actually graph it, the asymptote is y equals 0. It gets really close to the 0. Okay, guys, let's move on to the next one. Quickly. I know, quickly. Okay, so the next one is number 15. It says 4 graphs are shown below. Which one is the graph of the equation y equals -2 times 1/2 to the x power? Okay, the first thing is you don't even have to graph it yet. Not yet, because the first thing you should be looking for is that it crosses the y-axis at -2, right? So you check on your graphs. Ooh, here's -2. It doesn't even cross it. A is out. Let's look. Letter B. Ooh, letter B either. Look at that. Here's the -2. It doesn't cross it. So B is out. Okay, letter C. Okay, it's going through letter C. That one could be it. And then letter D, does it go through -2? Nah. The best one here is C. Okay, questions on this one? You see, I bet you're feeling better about these, right? When you took the benchmark, most of you were like, oh, what is this graph? And now you guys know what it is. And now you know asymptote, and now you can impress people. I know what an asymptote is. All right, guys, the next one, quickly. We're on page 198, number 17. An experiment begins with 20 grams of radioactive isotope. The equation y equals 20 times 0.5 to the x power models the decay of the isotope, where y is the mass in grams that remain after the x half-lives have elapsed. Which graph represents this model? So they already give you the equation. You just need to make sure which one matches it. So you can graph it on your graphing calculator and see which one's the best. You can also check your y-intercept is supposed to be at 20. So A looks pretty good. Ooh, B looks good. C looks good. D is out for sure. Okay, so now you have to decide between A, B, and C. So there's several things you could do. You could plug in a point and see if it comes out true. Or you could graph it on your graphing calculator and see which one's the best one. If you graph it on your calculator, you want to make your window the same as this window. That way you can make it look similar to the one on paper, okay? So from here, the best one is actually letter C, okay? Okay. I'm running out of time, but I just want to share with you the other examples, like number 19. I'm going to share with you the key, and then if you have a question, you just go back and check it, okay? So on number 19, which statement does not appear to be true? Number 19, the answer is B. Number 21, what is the y-intercept of the graph? That's when x equals 0. And here the answer is D as in dog. For number 23, what is the asymptote of the graph of the exponential function? You can graph it and see, but here's a little trick. Whenever you have the a, b to the x power, this number here on the outside, guess what? That's the asymptote, so that's letter B. Or you can graph it and look on the graph and you can see that it's -5, okay? Number 25, what is the equation of the asymptote? Oh, this one you should be able to see right away, right? What's the asymptote there? You see how it's approaching this line right here? So it is right here, which is letter D. Okay, the next one is number 27. Okay, so for number 27, it is B as in boy. And then number 29, they're pretty much asking you where it began, so that is the initial amount. And in this example, it is 120. And when you bubble it in on the griddable for algebra, you need to make sure that you bubble everything that you write in the squares, okay? You do not have to put the plus sign. I would stick to bubbling on the left side. It doesn't matter if you do the left or right, but I think if you start on the left, you can't go wrong, okay? Okay, guys, that's it. Your assignment is to do the whole thing for this one up to number 30, okay? So number 1 through 30 on serious, I want you to put the answers for the odds as well, okay? But you're going to do the evens. Just put all the answers.